Hey everyone, welcome to this session conducted by me, Amit, Timalsina, and today we'll be having a brief introduction to AI, which is artificial intelligence. Okay, now you may have already heard about artificial intelligence in various scenarios. You may think artificial intelligence as the thing that is generally integrated in robotics and all, but artificial intelligence is generally used in a lot of scenarios, and you can see clip here, just a screenshot. Reduction AI value creation by 2030, 13 trillion, and it will create a valuation in various industries, which is very much far apart from robotics. You can see here, retail 0.8 trillion, travel 480 billion, transport and logistics 475 billion, and so on. Semiconductors and electronics to 91 billion, and that's it. The source is McKinsey Global Institute. Okay. And now let's demystify artificial intelligence. You may have heard artificial intelligence till now as basically you may be understanding it as artificial general intelligence, which is such as it can do everything that human can do, such as humanoid robots. But we have a lot of time to reach this phase. We're currently in this phase is artificial narrow intelligence. Artificial narrow intelligence is a type of artificial intelligence where the artificial intelligence system or algorithm can do a specific one task, such as a smart speaker, such as a web search, such as a text transcript, text translation, language translation, which I mean. In farming and practice, they are just meant to do a specific task, which is such as categorizing a file as or mail as a spam file or not, as like those stuffs. And we have more than 1,000 years more, thousands, not 1,500 years more to reach this phase of artificial general intelligence, where the robots can do anything a human can do, and it may be more than a human can do. Okay, and let's now get started with what is artificial intelligence, and let's go into more deep, which is machine learning. Okay. Machine learning is the basically main part of the artificial intelligence, and machine learning covers a huge part of it. Machine learning is basically teaching the algorithm to do anything that we love to do, such as text transcript, spam mail categorization, and basically visualize computer vision like stuff. And the great hype in machine learning is generally created using supervised learning. A great hype of supervised learning has been created in the past few years, and I'll be saying why it is so in the next slide. Let me first say something about it. Supervised learning is basically kind of A to B learning, such as you give the unstructured kind of data, or it can be even unstructured data. Look, this is data which is generally input, and it is classifying it as output. And basically, we give the algorithm this kind of data, which is A input and B output. And the algorithm, that is supervised learning algorithm, it still categorizes the file. It still learns from this A to B category, B matching. It learns the algorithm behind it, just as such as we provide. This is A and B, which is input and output to the function. So the algorithm is basically let's say this, and it itself categorizes, provides us the output. It learns from this scenario, which is basically it. The algorithm itself learns this part. Algorithm learns this part. In other cases, it might be such that we provide a input, and the what it will do, such as squaring itself or that stuff, and it gives us B. But in this case, we provide input and output, and it automatically finds the algorithm behind it and gives us the output for the later inputs. So later you can provide the input of your choice, and it will give you the output according to the function that it has generalized itself. That's it. And the supervised learning is mainly used in various scenarios, such as this like input and output. I already told you about this. You generally receive a lot of emails, and the Gmail automatically categorizes some of them as spam file, which is basically done using the supervised learning, and it's called spam filtering. It's not a big achievement of artificial intelligence, what is major requirement, and you can also have an audio and text transcript. It's also a part of supervised learning, and it's basically used for speech recognition kind of stuff, such as Alexa and Echo and Tool Assistant. They all use this mechanism. And this is the text transcript or text translation. This is you can translate the text from English and English to Chinese. This is called machine translation. And this is the general. Might have seen this a lot, but I haven't thought actually what is it. And it's kind of the when you visit some kind of website such as Garage or Amazon, you often see there that when you see some of these stuff, then you're automatically recommended with some of these stuff that you have sourced based on what you sourced previously, which is the algorithm itself uses the user info and all the data that you have seen previously, so all the products and kind of stuff, and then it checks whether it provides us with that kind of ads and checks whether we click it or not, and then it itself optimizes its algorithm and sends us other ads and finds out which ad are we mostly clicking on. And this is the mainly used by online advertisement sites, and this is generally used for self-driving cars, image and data information. Basically, the self-driving cars have a camera in front of them, which takes the in front and sides, which captures the pictures in the real time and sends data to the cloud, and returns back you the information about which path you want to follow. It requires a deep algorithm. Let's not go deep into that. It uses the image and data info and provides you the position of the other cars. It's basically using self-driving cars. Okay, and this is the kind of technology that algorithm that is used in the machines. So that in the industries where you just like take an example that you are manufacturing phones in the industry, and you just took a picture of the phone and try to check whether it has some defects which can visually detect it, such as if there are some scratches or light stops, and the algorithm itself detects whether it has the scratches or not and classifies it and helps us to do the task more effectively. And it also optimizes itself based on the results that it got and the results that we were expecting. That's a deep issue. We'll cover that in the later process. Okay, now I'm telling you why the hype of supervised learning is so great now. As you know that in this internet era, the amount of data is going and increasing, because previously we used to have the data in the form of text, and now we have the data that is stored in these documents, is in the form of computer files and documents, due to which we have a lot of data that can be used by artificial intelligence for data inspection or data to collect data insights from that. And for a supervised learning to have a better performance, you need to have a lot of amount of data. And the previous algorithm used to have this kind of phenomenon like this. Look, this is the old AI models. It's ML models. That's mine. Look, they used to, in spite of having a large amount of data, this is called big data estate. They might have a lot of hype. There's a lot of hype around big data, and I hope I will be clarifying that to you today. Let's see. This is the big data stage, and if we use the old ML models, then the performance increases to a certain extent, and then it stops increasing its performance. There is a algorithm is itself not able to increase the performance based on the data, and we are in the neural networks era, that is deep learning era. This kind of supervised learning era. Look, small neural networks can even do better than the old AI models. Small neural networks means small supervised learning models or kind of deep learning models. Let's right. Small, it's not most clear. Small neural networks. Look, you can see even here that the performance is not improving a lot. So you can even increase you can go to medium-sized neural networks, and then you have the large neural networks, which basically provides you with both performance and which provides a large amount of performance based on the data we provided it, and it's the highest limit that we have reached to today. Deep neural networks, very deep neural networks. Let me simplify it as high. Look, to reach at this point, you can see to reach at this point, look, you require a lot of data. That is a lot of big data. It's called big data in this era. Uh, so to create a kind of model which works this amount of big that you have to require a large amount of data and you have to require which increases the performance to this extent. But let me clarify you one thing that to perform an operation on this big data or to fit a model on this data, you need a large amount of computer performance. That is, you need to have the modern devices such as GPU kind of stops to run this data frequently, efficiently, and fastly. Otherwise, if you run on the normal PC or systems, then you will end up getting nothing. Okay, now let's go to the next slide. Okay, now this is the interesting part of what is AI, and in deep we are going to study. Just obviously we are going to study about what is data. The example of data table, example of a table of data set. You can see here. Here you have this size of house data, and you have the price data here. If you input a neural network, provide this data, we are just in supervised learning until now. This is A, let's categorize it as A, and let's tell it as input, and let's tell it as output. You can see here that when you provide the neural network, firstly what you have to do is you have to provide the model of the algorithm with both of the data, A and B. This is this sort of data, and then the computer figures out the algorithm in between of those. The neural networks figure out that, and then after which you provide this provide a new data, then it tries to predict from that data the price of the house, and that's the kind it works. Let's not go into technical stuff right now. Look, when you provide A, the algorithm provides you with B. Okay, when you provide this algorithm provides you with this output, and you can just think of when you provide the size of the house, then the algorithm provides you with the price of the house. This can be generally used by the what we call brokers kind of stuff. Brokers, yeah, this kind of data set. Now let's go to this. You want more generalized form, that is, you want to provide even the number of bedrooms, and you want to get the output. Then you can categorize them as A, and this as B. Now it's not mandatory that you have to just use this as A and this as B. You can use any form as A and B. You have to just use the input and output as per the algorithm that you are trying to work on, as per the output that is required. And here you can provide the size of the house and the bedrooms, number of bedrooms required, and you will get the output and the price. Okay, and you get the price, and you can even just in this case it's input and it's output, but you can even use it to use this as output, and this as input. You can provide the price of the house by input, and you can get the output as the number of bedrooms you get in that house, the size of the house that you get. Okay. Now let's go to the next slide. This is a kind of supervised the data that is used by supervised learning. Here, if you want to build a phone system, that is some kind of app that can categorize whether it's a cat or not, and it basically feed the system with the pictures, and it generally tells you whether it's a cat or not. Look, it's not basically the major use case of supervised learning, but it can be easy to explain you with this. The system generally takes pictures as input A, and it provides you with labels as label. This label is basically notified as output, okay, and it gives the output as cat. Okay. Now let's go to how you can acquire data. There are basically various forms of acquiring data, and the most widely used kind of that is manual labeling. How do you do that is basically you or you can have someone else to categorize the data as to you, to label the data. You can label this picture as this input as cat, this what is it, this kind of bird, or as non-cat, and this you can do like this. So you can just do manual labeling and provide the algorithm and have an algorithm to learn on basis of this. You can have another form that is from observing behavior. So you can have a, this is called, okay, let me explain this later in the slides. Okay, let me stick to this now. And you can look from this table, which is kind of table. And here you have user ID and time and price and purchase. This kind of online marketing, online purchasing stuff. The user with this ID is at this time was shown the price of this for any kind of stuff, and he just purchased it. And the user with this ID at the time of this he purchased with the price of this purchase. This you can get insights out of this data. Basically, data is used for getting insights out of it. This kind of stuff done by data scientists and data analysts too. Okay. Now you can even have this kind of data and data of your systems in the industry kind of stuff. You can see here the machine this having temperature this and pressure this. Zero sort of no fault and machine with yeah. Is there any queries? Here the system when the system got to the temperature of this 140 degrees Celsius and pressure this, then the machine sort fault. Now when you get insights out of this, then you can feed you can feed this data to the ML model, and it can just get improve this model and just give us more useful data. Give us more useful output. Or you can even use the data, download the data from the website. This is basically you have a kind of stuff called transfer learning in ML, and you can use the data model which is trained by the others to use it in your model. Even if you have small data, you may have the one whose model you have downloaded. You have trained the model with a large amount of data, and even if you have a small amount of data, then you can train the model and have a proper model. In this case, you can even have you can get a large number of data sets provided publicly, and you can use those data sets to just get insights out of it, or even use it for getting into the ML models. Or you can even have the factory or the company where you are working may have collected the data with these data sets, and you can even use those data sets to get insights out of it or to train your model with those data. Okay, now let's go to the use and misuse of data. I think this is the second last slide. You can see here. Don't throw data to add an okay. Okay. Let's stop. Let me explain it to you. A lot of AI companies today, IT companies today, they think that they will collect data for about 3 to 4 years and get a huge amount of data and use those data to create a AI model which can be used by the company. But it's not true all the times, and mainly it's wrong a number of times. IT companies do this mistake that they just go on collecting data without acknowledging the data with the AI team, and finally cause to get a lot of errors out of it. It isn't always true that when you have a big data, you obviously require big data, but when you have big data without, which is not properly usable by the AI engineers, then you cannot get valuable algorithm or the model out of that. So you must always consult with the AI team to get the data, to collect data from your IT industry. And basically, when you show the data when you consult with the AI team, then they can suggest you to how you can get more useful data. Just you can collect the data in 5 minutes. You can collect a single table of data rather than you are collecting now with collecting a table of data in about half an hour. They can suggest you to work on this. Basically, to create an AI company, you have to work with a business team, IT team, and AI team to get a proper model out of that. Okay, now let me tell you that data is a lot messy. When you feed the data when you feed the mesh system with the wrong kind of data, then you get a lot of issues with the model, which you will be encountering if you go on running artificial intelligence. You might have already heard about garbage in, garbage out, and it's kind of stuff that when you feed a model with the wrong data, then it generally classifies the input you provided with the wrong output, and it creates a huge burden for solving this kind of issue, and it's generally not solvable, I think. Okay, and you can have different varieties of types of data. You must know about them. You have generally multiple types of data. This kind of data is generally known as unstructured data, as it consists basically of pictures, text, or the MP3 files, JPG and PMP files, text images, and just you can use this data to feed the ML model to make the ML model learn out something useful out of it. And you also have this, which is structured data. I missed it. Okay, I'll be covering it in a while. And this is called generally structured data. Structured data. This is kind of called structured data, and you can it's generally used by the data scientist team, or you can even convert this structured data, which is generally in the .csv file, into the other files you guys into the series data or the data frame. It's not your stuff now. Okay, let me tell you the data other data problems, which is under the category of data is basic. Incorrect labels. You generally provide data with incorrect labels. That's what you can see here. You have provided label as here as unknown, which creates which confuses the model. What is this unknown kind of stuff? And you have also left here. Look, missing values. You can see a lot of missing values here. We have left here unknown, unknown. You can even see here. You have here 645. You have provided the size of the house at 645 square feet, one bedroom, and you are writing the price at $0.001. And it's kind of possible to get a house at this sort of price, which is not possible at this time, and which generally causes the model to learn false things, and you can have a lot of problems data, and you have a lot of missing values here, which can even create a lot of problems data. You should always try to get a well-managed data. Let me now teach you some kind of stuff that I must not teach you, but let me just so you tell me at the end, did you get it or not? Okay. In the normal systems, what I do is you have a function. In the normal programming stuff that you do in Python or C++ or any other language, you basically have some kind of stuff like FC. I provided this. You basically provide the system with this function, the input, the A. You provide an input A, and this kind of stuff to the system. This is kind of input which you feed to the system. This you feed to the system, and you get some kind of stuff such as B as the output of the system, where you are just providing the algorithm as well as the input data, and you are getting the output out of it. And this kind of stuff is general programming stuff. And the fun thing about machine learning kind of stuff is that, and the fun thing with the ML model is that you basically have to provide input data. While training, you have to provide input and output both. While training, just while training, and the model itself finds out what's the function is basically in between of them. It basically finds itself out the function, what is the function, what is the relation in between of them. Just you provided A as 2, and you got output as, you provided B as input as this, and output as 4, and like 3, 9, 4, 16, which another one link can easily signify what it is. The system itself signifies that it's a kind of A square kind of stuff. This is the interesting thing about the ML model, which is a lot to study. I'm just giving you some kind of hint. And when the machine learns that it's A square, then you can just provide the system with, let me say, I provide a system with 5, and it automatically just labels my data with 25. And this is the stuff that the ML system itself learns. And this is all I think about today. I had something more to show, which I didn't complete actually. I was running out of time. Let's discuss about this in the data sections. Now you can provide any queries that if you have.